Okay guys, we're going to graph linear inequalities today. This will be number 17 in your toolkit. You want to jot these things down at the very top of your toolkit, and then I've got some graphs for you to put for examples. First thing is, from last week we remember that we had open and closed circles when we were shading before, and I hope you recognize that these two situations talk about our open and closed circles. Okay. Last week, when we were in this situation over here, we would use a closed dot on a number line. Well, now that we're in an XY plane, we're going to use a solid line. So solid line, solid dot, they kind of mean the same thing. On this side, the dotted line is going to be the same thing as the open circle on our number line. So a dotted line and an open circle both mean that the borders do not count. Okay guys, what we're going to do is I'm just going to pick a random dot here on my coordinate plane, and we're just playing around for a minute. We're not really graphing yet, but I'm going to plug in those dots, and this is how you can check to see if something is a solution or not. So you can see that when I plug in 6, 2, I plug in the 6 for the x and 2 for the y, and I solve. I got 2 times 6, 12. 12 minus 3 is 9. And in fact, 2 is less than 9, so that is a solution. So I put it in a green dot just because I knew in advance. But it does work. Now I'm going to try another dot over here. This one happens to be red. See what happens with it. Alright, so I'm going to plug in that red dot there. That's the point -3, 1. And you can see that when I plug in -3, 1, it ends up being a false statement because 1 is definitely not less than -9. Okay? Now, as a class, I asked everybody to come up with random examples of ones that worked and ones that didn't, so you can watch the ones that work and the ones that don't. And as you can see, they started dividing the paper up into two different places. So what we did then is we just kind of looked at what this inequality was trying to tell us. So we're going to graph that inequality. Notice it looks a lot like y equals 2x minus 3. Whoa. Alright, as you watch it get graphed in blue, you can see that the blue line, it does perfectly separate the green dots from the red dots, with the exception of this one right here, and we'll talk about that one in a minute. Okay? But that gets us into where we're actually graphing. So we normally wouldn't graph all of these dots, but I hope you can see that the green dots are all solutions and the red dots are not. So we're going to graph it the correct way. Okay. What I recognize from our notes at the top of the page is that a less than sign is going to be a dotted line, and I'm going to shade below because that's what a less than sign means to do. So what I'm simply going to do is graph my y equals mx plus b, 2x minus 3, start at -3 and then do a slope of 2. You can see it makes a line, and then you shade below, and I hope you recognize that this graph is exactly the same as this last graph, and you can tell that all the green dots worked and all the red dots did not. Now let's talk about this one. Why did that one dot that was on the line not work? Well, it's because it was not equal to. It's only less than, it's not equal to. So in fact, the border does not work. Okay. Next problem, same idea. This time we're going to do this same thing. So we're looking here. Y is less than or equal to. So first thing I want to recognize is that that's going to be a solid line, and I'm going to shade down. Now once you recognize the solid line and you shade it down, go ahead and graph your line. Start at 3, go slope of up 1 over 2, up 1 over 2. It's going to be a solid line, so I'm going to connect that, and then I'm going to shade below. And again, it's going pretty fast now, so I would encourage you to stop and pause. Third example, notice it's a greater than sign, it's dotted, and that's from the notes at the top of the page. and then we're going to shade up. And on this one, I want you to notice that this border does not count. The border does not count. So that's why I left it as dotted. Okay, these points would not work in this inequality. Greater than or equal to. That's going to be a solid line this time, so it will count. And I'm going to shade up. So there's my y equals 2/3 x minus 6. I started at -6 and went up 2 over 3, up 2 over 3. And then because it's a solid line, that means that fence does count, and I'm going to shade up because greater than means shade up. So all of those points would work. Final equation is a little bit different. It's a not equal sign. So I'm not really sure about the graphing on this one, but I do know from our beginning that it's going to be a dotted line. So I do the dotted line there, and I'm not sure which way to shade. So which things are not equal to x equal 2? Well, anything not on this line, so everything below it, and at the same time everything above it. So in this case I actually shade everything except the line. Alright, I encourage you guys to replay this as often as you need to. Hit pause and slow down when it's time for graphing. And we'll see you tomorrow.